Hey everybody, I'm back with a couple of additional revisions to my CNC router limit sensor. For those of you that are not familiar, this is a Hall effect limit sensor, and basically it works by taking a magnet and moving a magnet close to it, or moving it close to a magnet. And the Hall effect sensor, which is this guy right here, when the magnet gets close to it, it acts like a switch, and it goes from normal or green to red alarm state. And it basically, when that happens, it tells the CNC router to stop. If you didn't have something like this, your CNC router would crash. And what they mean by crash is it tries to go beyond its physical capability on either the X or the Y or the Z axis. And when that happens, you know, things start grinding, and it's just not good. So limit sensors are good to have. If you're good at setting up your router, you could actually get away with not needing them. But there's another very useful feature for these, which is homing. In this case, same sensor, same work. And what the CNC router does is it uses it to home to get to an exact spot on the table. And if you have an exact starting point that's repeatable every time, then for your projects you can base your movements from that exact spot. And that's what I use quite a bit. Especially if you have to have bit changes and things like that, you want to always be able to start from a given point. But in any case, this is my newest version of my sensor. My previous version of the sensor had a little bit more complicated circuit, and as I learned my electronics, I realized there was a way to simplify the circuit, which I did. The other enhancement that I did was I added this little wire block here, and this wire block allows you to add and remove wires without destroying it, damaging, crimping, soldering wires. My previous version, you have to solder the wires to the board, and if you need to make change or whatever, it makes it more difficult to connect and disconnect. So I wanted to be able to easily connect it and disconnect it, and obviously I didn't want to have to change crimps or damage it at the same time. In addition to that, I sell these sensors on Tindy, so I didn't want to have to sell them. I didn't like selling them with wires soldered right to them, because the person buying them, depending on what they're doing, they may or may not want those wires. They may want different colors, you know, a whole bunch of things. You know, then they'd have to add a plug to them, or they'd have to solder the wires I provided to whatever. It just, you know, to me it didn't seem like a good ease of use solution. So by offering this block on them, I eliminate that problem altogether. The wire block will accommodate a 20 to a 26, maybe even a 28 gauge wire. I recommend 22. That's what I use. I use stranded wire, and I even you know, twist the wires up and either tin them or just twist them up nice, and they insert right in. They go right in, and it makes ease for disconnecting. Let me show you how that works. Well, before I do that, let me talk about a couple of other things. The other thing I did was I send these boards out to be professionally manufactured, and when you do that, let me orient this way. When you do that, you get something that looks like this back. Very cool. Huge differences here. One is the board from the manufacturer is silk screen. There's writing on it. There's a solder mask on it and everything, and it's on both sides. So it actually helps protect the circuit. Whereas mine doesn't have a solder mask, you know, and it doesn't have the printing and all the other stuff on it. So it doesn't look as nice as this. However, equally functional. As a matter of fact, my router has the homemade ones on it. I haven't bothered to change them out, you know, because it's not necessary. Again, I do it because I want to, you know, I want to sell a nice looking product. And here's what the product looks like when it's completely assembled. I'm going to scoot this here. Let me get this guy out of the way here. Here's what it looks like when it's fully assembled. Okay, again, looks great. You know, both equally functional. They'll both do the same thing. There's no difference in capability. It just looks nicer. The other thing is when you solder these down, because the holes are sleeved and everything, you don't end up with as much solder on the surface, so it sits a little flatter on whatever you're mounting it on. Whereas with the homemade one, since there's no solder mask, the solder can spread out a little bit and it tends to pull up a little bit. Again, this still works fine. Like I said, I still have them on mine, but nonetheless, it makes it a little easier. But let me show you how easy it is to connect and disconnect these. Let me get these other guys out of the way. So if I take some breadboard wire, which is, I believe, 20 gauge. No, it's 22 gauge, just like I use on my router. And as you see, let's see if we can do this here. So what I'll do is, this is black, so I'm going to go into my negative, or my ground. Just push it, and it slides right in. Okay, see that? Goes right in. And then I'll get my positive lead. Okay, can you see that? Yep. And it goes right in. Okay? These are not coming out. There's no way these are going to come out. I'm either going to rip the insulation off this, or God knows what. But it's certainly not going to come off the board. Now, let me show you how it works. Get my little 5-volt power supply here. This is a 9-volt battery with just a simple 5-volt regulator that I put on it so I can quickly power projects without having to plug into stuff. See if I can get that in there. I am going blind, so I apologize for my taking forever to get these things plugged in. See if we can get my wire straight here. There we go. Alright, good. And turn on my power, and there you go. You can see, now I get my magnet. Magnet comes close. Green light comes on. Magnet moves away. I'm sorry, magnet comes close, red light comes on. Move away from the magnet, green light. And essentially all that's happening here, this is no different than a mechanical switch. A mechanical switch is just grounding out the circuit, or closing the circuit to the sensor, and the Hall effect sensor is doing it through some transistors. The same exact thing. The router doesn't sense any difference in voltage. It actually might even be sensing a little bit less voltage. This is a little bit more economical than a limit switch. I've had a few people ask me, hey, what happens if this gets covered with sawdust and debris and everything? Not a problem. Some people have said they'll cover them in plastic, they'll seal them in plastic. It's not necessary. Mine are always crudded up. They never have a problem. I brush them off once in a while, but no main issue there, works fine. Let me show you how easy it is. Let's get this turned off. Let me show you how easy it is to disconnect these wires. And this is really, to me, the biggest advantage. So again, we have our wires. Normally there'd be a third wire here, a sensor. This will be the sensor wire. So this is what actually goes to the router controller to actually sense, oh, there's a problem, stop moving. Let me show you how easy it is to disconnect these, okay? I use a bobby pin. I'm sorry, I keep saying bobby pin. I use a safety pin, just so you can see what that is. Just seems to be easier. It's at an angle. It works for me. But essentially, all you do, let's see if we get this so you can see what I'm doing here, because I know that's got it zoomed in. But you take it, you put it in the hole right above the wire you want to release, push down on it, pops right out. We go and do the other one, push right on it. You can see, actually, if I turn it over, it falls out. See that? And then you just pop it out. And the nice thing is you can just stick it right back in. Nothing's broken. Nothing's damaged. Okay, and then my red one, for positive, again, goes in that hole. There you go. These are not coming out. So that's what I really like about that. Now, the other problem that I encountered a little bit, not really, a little bit, but I came up with a nifty little solution to that too. Let's get those out of the way for the moment. That out of the way was, when you mount this, I'm a big fan of hot glue. It doesn't damage anything, it's removable, it's really cool. So when you mount this, you can put a hot glue on the back of that and stick it right down. The only problem is that if you're not super careful and you happen to be doing it on metal, you could potentially short this. These are pretty tough, they're hard to break, so don't worry about that. But it may not work when you need it to work. So I came up with a little idea. I made myself a little tray to install these on. I have a 3D printer also. So take this, take the board, set it right down in it, and voila. Did I put it in right? Yeah. There you go. And it sits right in there. Now if you just, I was going to make it friction fit, but you know, I decided not to. I came up with another idea for that. So instead of friction fit, you guys ever heard of Fun-Tac? That's great stuff. It's like sticky stuff and it comes off. So the Fun-Tac is okay for inside the chassis. That's likely not to move, but I would still use hot glue on the outside of this and go on, because the hot glue is a little bit more robust. And there you go. Nice little package. Holds on, works out good, looks good, and it's totally insulated. So now you can mount this on metal if you need to. If you're not mounting it on metal, then you can mount it directly on whatever. You don't need the little board to hold on to. So, you know, my only other thing I can do to this is make an SMD version of this, which I do have. I don't have it with this wire block on it, and as you can tell, this wire block does take up quite a bit of real estate. So the SMD version, I could make this, you know, probably the size of the block alone, but because of the block, I'll have to double it in capacity. Now, I don't know, the SMD version that I have, it works and everything. I just wasn't crazy about it because the lights just weren't as bright because they were small. Maybe I need to use a different package, and I might do that at some point. I have some other projects I need to work on. But in any case, this works out well for those of you that are losing your eyesight like me. Makes it a little easier to see. I think that's it. If there's anything you have any questions on or would like to know more, or you know, any suggestions, I'm always open to suggestions. I'm not always very creative, and so coming up with suggestions can spawn other ideas. I'd really like that. And I will give myself a little bit of a plug. If you're interested in buying any of these, they're available on Tindy, or you can email me directly through the YouTube link. I really appreciate you guys listening, and if you don't mind, give me a thumbs up if you like it, and hope you have a good day. Thanks, I appreciate you watching. Bye.